Hi everybody, Professor Muhammad Shah with you. Um, Today it's I'm not sure if anybody hear me. Yes. Our stream today is about how to connect between two different models based on a common link between these two models. Suppose we are going to talk about a concentrated solar gas engine. It's a very interesting model, and beside of this, we have to combine between reverse osmosis desalination plant. Both models are design aspects. It is not performance. Therefore, we are going to demonstrate how to connect between reverse osmosis and concentrated solar gas dish engines. Suppose I have two models. Suppose this is the first one. This is concentrated solar gas engine. Okay. We demonstrated this before, so we are not going in details. We're just showing how to deal with it. It's about a solar gas engine. There is a Stirling engine or Brighton engine in this in the centroid of the dish. So you can generate very impressive power because the concentration ratio is massive, as you can see here. So you can choose between different engines. Suppose I'm going for Stirling gas engine, most common, most efficient, and you can choose between 12 different gases: monatomic, diatomic, and polyatomic gases. Suppose I'm going for like carbon dioxide. Okay, carbon dioxide. Okay, in this model you can assign your total power. Suppose you are going to design your plant for 1 megawatt, and you need how many dishes you are going to use. Okay, so you can choose, you can select rim angle design. Okay, and your top cycle and bottom cycle temperature and bottom cycle temperature. For operating conditions, what is your operating hours, solar radiations, atmospheric pressure and temperatures. If you are going for a Stirling engine, you have to assign the engine, individual engine power. Here we assign total plant power, but for Stirling engine we need normally around from 25 up to 30. There is some new modules. They are talking about 60 kilowatt per engine. Anyway, so you can assign instead piston diameter, number of cylinders, and engine speed. For Brighton, we just need Brighton engine power. Okay, suppose we need 25 kilo per engine. And performance, generator efficiency, receiver efficiency. Okay, I think this is from 70 up to 80, 85. You can choose material of the mirrors, because there is mirrors here, absorptivity, and cost elements or terms. Okay, anyway, so this is for a gas engine. Okay, you can specify your inputs in order to get some outputs, such as design. What is your dish area, total plant area, dish diameter, height, proper height, receiver area, receiver diameter, angle ratio, focal length, number of dishes, and so on. As you can see here, this is a photo of the solar gas engine, dish engine, and cost analysis. What is your total plant cost and so on. The same for Brayton cycle. Okay. This is our concentrated solar gas engine. Okay. For reverse osmosis, let's go for reverse osmosis model. Okay. As you can see here, for reverse osmosis model, we demonstrated that just 2 days earlier. Okay. You can assign, this is desalination, membrane desalination, so you can desalinate seawater, okay, up to seawater, brackish water, okay. You can choose between three types of configurations: basic module, pill-to-wheel drive, or pressure exchanger. Suppose I need to go for basic configuration. Okay, you can assign your salinity, ambient temperature, seawater temperature. Okay, plant productivity 3,500 meter cube per day, number of pressure vessels for almost 42 suitable for this, number of elements per pressure vessels, number of pressure vessels, high pressure pump efficiency, recovery ratio almost 30%, fouling factors, and this part is for pressure exchanger. Okay, so and you can if you choose a basic module, you have to go to basic module and extract your outputs. Okay, we have 3 types. This is pill-to-wheel drive, and we have here reverse osmosis pressure exchanger and basic module. Okay. Okay. Suppose we are we need to power on this plant by the use of concentrated solar gas engine. Okay. Let's go step by step and see how we have here. As you can see, we have 2 different models. Okay. Okay, this is reverse osmosis model, and we have here Stirling engine model. I'm sorry. Okay, so we have 2 different models. Okay, 2 different models, as you can see here. Okay, what we should do now. Okay, you have to go here. Suppose I'm Stirling engine, and let's see first file. Okay, new blank model. Okay, this is our new model. That's our new model, and you have to go to the view and model browsers. Okay, show model browser. Okay, check all of these buttons. Our simulation time is 0, and going for this is our preparations. Okay, we are preparing our okay, fixed step, solver, automatic or discrete, it's up to you. And there is no need for signal. Okay, no need for this, or timeout, optimization, the diagnostics, none, and otherwise algebraic group, none. Okay, that's it. Apply, and we have to save this. Suppose it's concentrated solar gas engine for reverse osmosis energy recovery device. Okay, that's a new model. We have to save this. Okay, we prepared our landscape or model, and now we need to just copy and paste. Let's go for here, Control C or copy. Okay, and this is our blank model. Paste it here. Okay, Now this is the first part. The second part is to go here. So, okay, you can copy or drag and drop. Okay, okay, copy and paste it here. Copy and paste. You can use this logo also. Okay, now this is our environment. This is our model environment, and we need to prepare everything. First of all, let's unify our let's go here for example, this format, font style. I do prefer Times New Roman. Okay, okay, that's fine for this. And we need I will check if we have four iterator. Yes, 4 iterator here. Let's Control X this one. I will remove this 4 iterator, put it here. Oh, I'm sorry. Oh, because this is okay. Okay, we have to you can create sub block from here. Okay, we can create sub block. Let's go here and make create sub block. Maybe later I will do this. Maybe later. Okay, Control Z, returning for. And with this Moses, we have also 4 iterator here. Yes, okay. I will leave this till now. Okay. What is? We have 2 different models. Okay, what we can do now? What we need to do actually? Okay. For Reverse Osmosis, Reverse Osmosis will tell us how much power do we need. Okay. So for basic module, we need to discover module area, specific power consumption, pressure difference, power, and this power stream is mainly responsible from solar gas engine. So we need to take a stream. It depends on your application. So our application, we need from here, we need to connect between 2 different models. I mean, the power from here, from this engine, is responsible for the operation of high pressure pump as a reverse osmosis. From as a power from concentrated, from solar gas engine, is responsible for power generation of reverse osmosis high pressure pump. So, but we have 3 different modules, so we need to take out 3 streams from each module. Let's go for Simulink and sync out. Okay, and we have to check from here. Okay, and we have to name this. Suppose it's I'm going to name it as high pressure, high power, for let it be high power 1 or basic. Okay, basic module. Okay, this is the first stream. Okay, and let's go for, we are now in Reverse Osmosis Plant. Okay, but first I have to, let's go here for 1 concentrated solar gas engine, and 2 is reverse osmosis with energy recovery device. Okay, 1 and 2 for reverse osmosis. Let it be, this is 2.1. okay, 2.1, and this is 2.2, and this is 2.3. okay, and for gas engines, okay, for gas engines let it be 1.2. okay, for this is Brighton, 1.2. okay, and this is 1.1. okay. Now we prepared our model environment. okay, let's return back here. okay, going for we extracted our first stream from the basic module of reverse osmosis, and we need to extract another one. okay, where is our power? okay, this is power, output power. okay, this is petrol wheel drive. So the power from petrol wheel drive is subtracted from the total power of the plant. So we need, suppose I'm going, yes, let's go out and put it here, and let's check another stream here. Let it be high pressure, high power petrol wheel turbine. okay, this is another one. And for pressure exchanger, okay, this is our consumption power. okay, let's go here for pressure exchanger, and we have to name this high pressure PEX pressure exchanger. I'm sorry, high power pressure exchanger. Therefore we have 3 output streams, so we need to collect all of these streams to be outed for the solar gas engine. I have to, okay, we have one here. I'm sorry. Okay, we have another one here. Okay, this is our basic stream, and we have here another stream from here, and we have another, the third one is from here, pressure exchanger. okay, so we need to, let's go for go to, right click and drag here, Control I to swap this direction, and we have to put here, I'm sorry. okay, I will name this high pressure basic. okay, I will name this, I'm sorry, not high pressure, it's high power basic. okay, and let's emphasize this. okay, drag, Control I, and we have to put it here. Sorry, yes, we have to name this high pressure filter wheel turbine, high power again, high power filter wheel turbine. okay, I'm going for this one. Let's drag here. okay, and this is high power pressure exchanger. I hope we can move this time. PEX. okay, so now we need 3 streams. Let's go up. okay, we need 3 streams from here. Let's go for three inputs. Let's double clicking on this one and three inputs. Okay, and three inputs. Let it be number one, number two, number three. Okay, and this one update. It's high. First is high power basic. Hit apply. Okay, and second it's filter wheel turbine power, and the third is pressure exchanger. Okay, check this. Hold shift here and arrange, match size. Okay. I have to organize everything, and this is our output. Let's go for sync and choose our output. Okay, home, and we have to call this power in kilowatt. Okay, this is our power in kilowatt. I have to be sure this is in kilowatt. Okay, but first I have to check this, and going for, because we have three streams, I have to go for math operation, minimum and maximum, and choose this one. Let's go for maximum, because I need the maximum stream signal output. I put this here. Okay, so in run it will choose the right value from the maximum value that, or the desired value that I would like to extract outlets. Okay, let's return back out to our mother loop. So we have here, this is our power. Okay, I have to go here. You can adjust your position. Okay, this is power stream from reverse osmosis. Okay, or you can just Control I. Okay, and it's better to be here. Okay, this is outlet stream containing the power needed or loaded on the concentrated solar gas engine. Okay, for gas engine we have to prepare the input, because input is assigned by double clicking. This is our input, total power plant power. This is the total power. So we don't need to assign this manually. We have to calculate this by the use of reverse osmosis. So I have to Control M, open my dialog parameters, and going for parameters. Okay, this is total power plant. You can check this, enable and visible, remove this. Okay, so hit apply and okay, and if you double click here you will not find the power, it's moved. Okay, let's go inside, and this is our input parameters. So we have to going for total power. Yes, this is total power plant. So I have to save first. I have to remove this, Control X, remove this, and put inputs. Source, going for the source, and in. Okay, this okay, we can name this by, I'm sorry, home, and this is total power. Total power in kilowatt. Okay, so this is input power to the to the gas engine. Okay, now everything has been prepared. Now going here, so Control I. Now we have to connect between these two different blocks. So the power from we can ensure this by going to this Let's go for sync display in order to ensure our results. Okay, therefore the power needed or the power load by reverse osmosis desalination is going to be calculated from the concentrated solar gas engine. Okay, I would like to try this one. First of all, we have chosen here basic configuration. So the first model, this is the first one, is responsible for calculation. Let's hit run and see our results. I hope it can work. Okay, it seems good. So far so good. Okay, fine. So let's go here for basic module. This is our power needed by the high pressure pump, and this power is it's almost 1 megawatt. So this is the load on concentrated solar engine. If you check here, there is no solution because we didn't check petrol or pressure exchanger. There is no solution. Also for Brighton you will find no solution because we choose before Stirling engine. So if you're going here for Stirling engine, okay, fine. This is our result based on 1 megawatt load on concentrated solar gas engine. If you can see here, let's go for outside. Okay, so as you can see here, we have connected between two different models, reverse osmosis and concentrated solar gas engine. You can, this operation is for Stirling engine, carbon dioxide, okay, and 800 degrees Celsius as a top cycle and 25 degrees Celsius to bottoming cycle. Okay, so you can let's go dynamically if you would like. Let's go dynamically, or I hope we can let's go dynamically, but I think we can delete this for another video going dynamically. This is our result based on CO2 results. As you can see here, this is pressure ratio, maximum specific volume, minimum specific volume, piston volume. Suppose I'm going for here and select another helium, for example, helium. Let's go inside the Stirling engine and see it saving. Okay, different compression ratio, different specific volumes and areas and so on. So we can change our result. You can select. I need to remove this. Okay. So if you change your productivity here, suppose it's 1,500. Okay. I'm sorry. Let's go again. But if you reduced the productivity, so the power will reduce. Yes. So, for 1,500 meter cube per day, we need just 300 kilowatt of power, and this will affect on the area and the power and the cost of Stirling engine. Ensure the number of dishes. As you can see, this is number of dishes. I have to. I'm sorry. This is here. Number of dishes. We need just. Sorry. Okay, 14 dishes. We need 14 dishes in order to support our reverse osmosis plant power. Okay, I'm sorry, here I have to remove this. Let's remove this. Okay, finally I would like to thank you very much for your interest in our model. Today we learned how to connect between two different models. You can drag and drop, you can copy, as you can see here. You can copy many models. You can copy and you can make different stages of your reverse osmosis and different plants. It's easy, and I hope that you enjoyed our video today. Looking forward to hear from you in your chat or on your reply. And don't forget to like and share and subscribe. Thank you very much for your interest in our models. Thank you very much.